Hey folks, I'm going to go over a very simplified short version of our history of the past 13.7 billion years. And again, this is going to be simplified and very short. There's a tremendous amount of detail that I am leaving out, but, well, we'll just go from there. So the universe is about 13.7 billion years old. So 13.7 billion years ago, the leading theory is called the Big Bang Theory, and there's a tremendous amount of evidence to support it. What we believe happened is that we don't know why, and we don't know where it came from, but essentially some kind of bubble that was insanely dense and incredibly hot, smaller than an atom, was the entire universe. Anything and everything in the universe, all the mass, all the energy is inside of this bubble. It is held together by the superforce, which is all four of the natural forces put together: gravity, electromagnetism, and the weak and strong nuclear forces. Suddenly, for reasons we do not yet understand, gravity breaks away. Now, the rules of physics are different at this point because you have gravity as one force, then you have electromagnetism, weak nuclear, and strong nuclear forces, those three combined as one. In this breakaway phase, this allows the universe to rapidly expand and rapidly cool. Things can move faster than the speed of light. And the reason why they can is because the rules of physics are different during this period of the universe than they are today. To put this in perspective of how quickly this happens, it takes less than 1 second for all four of the forces to completely break away and become their own thing. In that less than 1 second, the universe is several billions of light years across. So we are talking about an incredibly fast expansion. The WMAP that we had talked about in our very first unit of the school year, the WMAP is a map of microwave radiation, background radiation, that we see everywhere in the universe. It shows this uniformity that we would predict would happen from the rapid expansion and rapid cooling. Now, what happens from there is about 3 minutes into existence, the universe is insanely massive, and it's cooled down enough that hydrogen can form, as well as helium. So why couldn't hydrogen and helium form before? Well, because it was simply too hot. You would not be able to form these particular elements. Now, over the next few billion years, it takes about another 380,000 years before light can finally first emit. I take that back. Light was being emitted, but it was instantly being absorbed. So it was sort of like shining a flashlight into a very dense cloud of fog. Sure, you are emitting light, but it's constantly being absorbed by the fog. And what happens is after about 380,000 years into the existence of the universe is enough stuff has kind of settled down and begun to clump together so that when light is emitted, it's not going to be instantly absorbed and then re-emitted in a different direction. So we really don't have any light that reaches Earth from the first 380,000 years of the universe. It's important to remember, if we look through a telescope and we look at something 12 billion light years away, not only are you looking 12 billion light years as a distance, you're also looking 12 billion years into the past. We notice things that the farther away things are from us, the smaller the galaxies appear to be, the more massive stars that are in that galaxy. And we also notice those galaxies are heading towards each other and are going to merge to form bigger galaxies. So that's sort of what happens in our first 380,000 years. 1 billion years into the universe, the first stars can form, and that's where we began the beginning of this unit, is these supermassive stars. It takes 9 billion years for our sun to finally form, as well as our whole solar system. Our sun formed out of the death of a supermassive star that went supernova, and I'm not 100% sure, but I believe it was around 20 to 30 stars formed in this nebula cloud, and one of those was our sun. That happened about 4.57 billion years ago. Now, as that happened, what our sun is going to do, and has been doing, is it's converting hydrogen into helium. It's going to convert about 700 million tons of hydrogen into 695 million tons of helium. What we do know about the universe is it's expanding. So how do we get this idea that we came from a singularity? Well, the universe is expanding, so if you played it backwards or in reverse, it would be shrinking, and it would shrink down to a singularity. That's what our mathematical predictions would indicate, and our observations of the universe are matching that. If this seems like it's a complex idea, that's because it very much is a very complex idea. Even Einstein himself thought that, one, the universe always existed, and two, that it was in what he called steady state, so it was neither expanding nor contracting. The irony is Einstein's own theories on gravity was exactly what was used to prove that Einstein was wrong about his theory about the universe. Einstein never lived long enough for the Big Bang theory to be well established and for all the evidence to be put together. But in the end, if you struggle to kind of wrap your mind around this whole idea, well, you're not alone. It took thousands of years with millions of human minds to piece this together. The idea, though, is 13.7 billion years ago, when the universe first formed, we had hydrogen and helium. Everything else was forged inside of a star or forged in the supernova. Essentially, the iron inside of your blood was made inside of a star. The oxygen you breathe to stay alive was made inside of a star. Your carbon-based life form and the food that you eat is carbon-based life forms. That carbon was forged inside of a star. If you have a piece of gold jewelry, that gold was forged in a supernova. So all of these things were eventually created by stars.